Now the next point is not too many passengers in the car. Now this is again important, okay? When you have a lot of people sitting in a car and airbags will be deployed with a lot of force and pressure in a fraction of a second. So when you have many people sitting inside a car, you can collide with each other and that itself can lead to injuries. And that's the only simple reason why it is not encouraged to have too many people in car. The last point is no child sits in front facing rear. Now you must understand airbags are designed for adults. When you have child sitting in the front, the position of airbag will not be effective in saving the life of child. And another important point to notice is airbags will be deployed in a fraction of a second with a lot of force. So the force can hit the child and leave bruises, or it can even lead to suffocation. And due to these reasons, child can experience severe damage. And for these reasons, these prerequisites are important and it must be taken care. So we move on to the next slide. As the purpose of airbag is to prevent the passenger body from hitting the car, not one airbag is enough. Let us now look at different types of airbags in a car. As you can see in this slide, different types of airbag includes front airbag, curtain airbags, knee airbags, and inflatable carpets. Let us discuss airbags in some more detail. There are three parts to an airbag system that helps to accomplish passenger protection. These include the airbag itself, crash sensor, and the inflator. The airbag is made of a thin nylon fabric which is folded into the steering wheel. The crash sensor is a device that tells the bag to inflate. And finally, a rapid pulse of nitrogen gas is used to inflate the airbag. So let us look at how does this airbag work. The working principle of airbag. When the crash sensor detects the accident, the airbag systems ignite a solid propellant which burns extremely rapidly to create a large volume of gas to inflate the bag. Nitrogen gas used to inflate the bag is obtained from chemical reaction of sodium oxide and potassium nitrate. So these two gases react with each other when an accident happens, and that leads to the outcome of an airbag. So with this slide, we complete the passive safety system. So before moving on to active safety system, I want to give some more fun facts. Okay, these are important facts to keep in mind. So the first one is in 1978, Bosch introduced the world's first anti-lock braking system. In 1986, Bosch introduced world's first traction control system. And in 1995, Bosch introduced the world's first electronic stability program. Now in this webinar, we are going to see each of this in detail with special focus on anti-lock braking system. So before I dive into these topics, I want you again to imagine something. That is, you imagine that you're driving a car after heavy monsoon rain, and due to wet and slippery road, there are chances that your car can spin out of control. That is, there are chances you might lose control of your car and meet with an accident. To avoid this situation, anti-lock braking systems are introduced. Our next topic of discussion is anti-lock braking system, or ABS as it is famously known. Let us start examining the purpose of ABS. There are two main objectives of ABS systems: maintain steerability of the vehicle and maintaining the vehicle stability during braking. I would like to take you guys to your childhood to help you understand anti-lock braking system. Let's see how we can understand anti-lock braking system by our childhood experience. I am sure all the participants would have driven bicycle in their childhood. I hope you would have also noticed a pair of brake pad that grips the wheel whenever you press the brakes. Basically, you're using brake pad friction to stop your bicycle. Now imagine you are driving fast and suddenly you have to press the brake hard. What do you think will happen? You will notice that your wheels will stop moving, but due to the momentum your bicycle has gained, it will continue to move forward before it comes to a halt. And imagine you have a car or some other obstacle in front of you, you can hit the obstacle. Though you have pressed the brake, accident will happen. Now let us revisit this situation with slight difference. Okay, so let's assume you're driving your bicycle, you're driving it fast, and you have seen an obstacle in front of you. And instead of pressing your brake hard, what you do is you press your brake for some time, and then you release the brake, and then you press your brake again, and then you release again. So by doing this, you are reducing the speed of your cycle, and at the same time, you're ensuring you have control over the cycle, and in case you want to move, you can move. Such braking principle is called cadence braking principle. And this cadence braking principle is the foundation of anti-lock braking system. So let's look how this will work with a car. Imagine if you applied hard brake on a wet road, you might not be able to steer the vehicle as the wheels might get locked. The car might continue in a straight line, however much you turn the steering vehicle if your wheels are locked. In such a situation, the driving technique to follow, the best driving technique to follow is to pump the brake while you also steer simultaneously. This technique is called cadence braking. These days, complex ABS system does this technique for you.